The next-generation network is body of key architectural changes in telecommunication core and access networks. The general idea behind the NGN is that one network transports all information and services by encapsulating these into packets, similar to those used on the Internet. NGNs are commonly built around the Internet Protocol, and therefore the term all IP is also sometimes used to describe the transformation of formerly telephone-centric networks toward NGN. The concept of future Internet refers instead to how the Internet itself might evolve. Description. According to ITUT, the definition is: a next-generation network is a packet-based network which can provide services including telecommunication services and is able to make use of multiple broadband, quality-of-service-enabled transport technologies and in which service-related functions are independent from underlying transport-related technologies. It offers unrestricted access by users to different service providers. It supports generalized mobility, which will allow consistent and ubiquitous provision of services to users. From a practical perspective, NGN involves three main architectural changes that need to be looked at separately. In the core network, NGN implies a consolidation of several transport networks, each historically built for a different service, into one core transport network. It implies, amongst others, the migration of voice from a circuit-switched architecture to VoIP, and also migration of legacy services such as X25 frame relay. In the wired access network, NGN implies the migration from the dual system of legacy voice next to XDSL setup in local exchanges to a converged setup in which the DSLAMs integrate voice ports or VoIP, making it possible to remove the voice switching infrastructure from the exchange. In the cable access network, NGN convergence implies migration of constant bit-rate voice to cable labs packet subl standards that provide VoIP and SIP services. Both services ride over DOCSIS as the cable data layer standard. In an NGN, there is a more defined separation between the transport portion of the network and the services that run on top of that transport. This means that whenever a provider wants to enable a new service, they can do so by defining it directly at the service layer without considering the transport layer, i.e., services are independent of transport details. Increasingly, applications, including voice, tend to be independent of the access network and will reside more on end-user devices. Underlying technology components. Next-generation networks are based on Internet technologies including Internet Protocol and multi-protocol label switching. At the application level, Session Initiation Protocol seems to be taking over from ITUT H323. Initially, H323 was the most popular protocol, though its popularity decreased in the local loop due to its original port reversal of network address translation and firewalls. For this reason, as domestic VoIP services have been developed, SIP has been more widely adopted. However, in voice networks where everything is under the control of the network operator or telco, many of the largest carriers use H323 as the protocol of choice in their core backbones. With the most recent changes introduced for H323, it is now possible for H323 devices to easily and consistently traverse NAT and firewall devices, opening up the possibility that H323 may again be looked upon more favorably in cases where such devices encumbered its use previously. Nonetheless, most of the telcos are extensively researching and supporting IP multimedia subsystem, which gives SIP a major chance of being the most widely adopted protocol. For voice applications, one of the most important devices in NGN is a soft switch, a programmable device that controls voice over IP calls. It enables correct integration of different protocols within NGN. The most important function of the soft switch is creating the interface to the existing telephone network, PSTN, through signaling gateways and media gateways. However, the soft switch as a term may be defined differently by the different equipment manufacturers and have somewhat different functions. One may quite often find the term gatekeeper in NGN literature. This was originally a VoIP device, which converted voice and data from their analog or digital switched circuit form to the packet-based one. It controlled one or more gateways. As soon as this kind of device started using the Media Gateway Control Protocol, the name was changed to Media Gateway Controller. A call agent is a general name for devices, systems controlling calls. The IP multimedia subsystem is a standardized NGN architecture for an Internet media services capability defined by the European Telecommunications Standards Institute and the Third Generation Partnership Project. Implementations. In the UK, another popular acronym was introduced by BT as 21CN. This is another loose term for NGN and denotes BT's initiative to deploy and operate NGN switches and networks in the period 2006 to 2008. The concept was abandoned, however, in favor of maintaining current generation equipment. The first company in the UK to roll out her NGN was Thus plc, which started deployment back in 1999. Thus, NGN contains 10,600 kilometers of fiber optic cable with more than 190 points of presence throughout the UK. The core optical network uses dense wavelength division multiplexing technology to provide scalability to many hundreds of gigabits per second of bandwidth, in line with growth demand. On top of this, the Thus backbone network uses MPLS technology to deliver the highest possible performance. IP, MPLS-based services carry voice, video and data traffic across a converged infrastructure, potentially allowing organizations to enjoy lower infrastructure costs, as well as added flexibility and functionality. Traffic can be prioritized with class as a service, coupled with service-level agreements that underpin quality of service performance guarantees. The Thus NGN accommodates 7 classes of service, 4 of which are currently offered on MPLS IPVPN. In the Netherlands, KPN is developing an NGN in a network transformation program called All IP. Next Generation Networks also extends into the messaging domain, and in Ireland, OpenMind Networks has designed, built and deployed traffic control to handle the demands and requirements of all IP networks. In Bulgaria, BTC has implemented the NGN as underlying network of its telco services on a large-scale project in 2004. The inherent flexibility and scalability of the new core network approach resulted in an unprecedented rise of classical services deployment as POTS, ISDN, Centrex, ADSL, VPN, as well as implementation of higher bandwidths for the metro and long-distance Ethernet, VPN services, cross-national transits and WEBTV, IPTV application. In Canada, startup Wind Mobile owned by Globalive is deploying an all-IP wireless backbone for its mobile phone service. India has set up NGN Lab at Odisha, which is capable of subjecting Internet Protocol-based equipment for conformance and interoperability testing. The government has planned to launch NGN in major cities of Maharashtra and Goa in financial year 2016-17, aimed at better quality broadband connectivity.